All right, so hello everyone. Can you all hear me well? All good. So my name is Ian Sulley. I'm an undergraduate student at Union College, and I spent this summer working on migrating the station image service from the old Gallery 2 platform to a new cloud-based solution. Currently there exists a Gallery 2 image database hosted by UNAVCO that hosts all images of all field instrumentation deployments out in the field. And this is primarily used by field engineers to basically catalog any sort of installation processes or maintenance visits that might occur to maintain all the field equipment that UNAVCO is responsible for maintaining. This system has been up and running for almost 30 years at this point, and it hosts 130,000 photos covering almost every station in the multiple different networks managed by UNAVCO. And as a result, the system is pretty old and needed kind of a refresh because Gallery 2, the backend system this is built on, is going out of commission and is no longer being maintained. So we're looking to upgrade the system to some more modern approaches and hopefully facilitate all the use cases that it was already being used for in the past. And so these are just some pictures of what the actual existing Gallery 2 database looks like on the right, and on the left are API endpoints that allow for programmatic access to bulk access of data within the database, primarily related to image metadata and station metadata associated with different installation or maintenance activities that field engineers will go out into the field and process. This is just another example of what those API endpoints look like. So for example, before a field engineer goes out and does maintenance, they might want to look at all the maintenance activities that have been processed in the past, and kind of this is their way of collecting any relevant information related to a station or related to a specific maintenance activity that's been performed. And basically, this is the system that is being replaced by the system that I've implemented, which is based on a new framework and a new backend database managed in the cloud. And so here's an overview of kind of what this album metadata looks like and the database schema of the Gallery 2 database. A lot of these things are a lot of the metadata information is embedded in file names, and this is all going back to almost when the platform was started in, I think, in 1993. So these have been used, these are fields that have been used for 30 years, and we need to support the previous data as well as any new use cases that might arise in the future. And so this is kind of the structure of what that database looks like. And here's some more metadata associated with some specific image files. So for example, there'll be, when a field engineer is in the field, they'll take a picture and they will mark what direction they're facing with the station in the frame, and they will name the file according to that direction, and you'll be able to programmatically access that through the API based on what you need for your maintenance activity. And so this legacy system hosted on a Postgres database server. Access is all done through a Flask Python web API. And this is kind of nitty-gritty technical details of implementation, but this was kind of the flavor of what software was used to host this previous Gallery 2 database. And so my project comes in here where we were moving away from Postgres database server and onto an AWS hosted cloud database, as well as a third-party database hosted by a platform known as Piwigo, which is another open source database, but it allows us to have all of our image data and the actual server infrastructure, the physical computers that this database is running on, is all managed externally by a third party, and is no longer requires maintenance from UNAVCO personnel. So the first kind of migration that needed to be done was going from Gallery 2, which is a database hosted on UNAVCO servers, to this cloud-based platform known as Piwigo. And since Gallery 2 had gone on unmaintained for a number of years, it was becoming a costly process to maintain new features and patch bugs as they arise as the system grew older. Meanwhile, Piwigo is another open source photo management platform that supports a lot of the same uses that Gallery 2 supported. However, it is much more actively maintained currently, and it still is, it offers cloud hosting and professional support through a paid tier system, so that a lot of the difficult technical management of physical infrastructure no longer has to be handled by UNAVCO and instead can be handled externally. So this is an example of some of the images that have been moved over from Gallery 2 to Piwigo. There's this home gallery image page, which is basically categorized by stations. Each station has a unique 4-character ID. And then within a station album, you'll have individual photos taken related to that station. And then those photos will have a variety of metadata associated with them, such as what sort of activity was being recorded in that photo. Was it an installation versus was it a maintenance visit? And other information such as what direction was the camera facing, when was the installation occurring, or whatever activity therefore was occurring. And really any relevant information that a field engineer might need when they go out into the field to visit these sites and perform any services that may be needed. Additionally, we moved from the API access to the database that I spoke about earlier, from Flask to Fast API, whereas Flask is still a popular choice for Python web development. It's not as current as Fast API, which has a few exciting features for future-proofing kind of the future of this service, and hopefully will take it another 30 years. So Fast API allows us to do some data validation, which ensures that the data that we're expecting to be returned from the database matches with what is actually being returned. And this is something built into Fast API that's really beneficial in just keeping sure that data integrity remains high and the system is working as intended. Also, some of the documentation around how to interact with the API is built into Fast API and auto-generated, so that it's really easy for someone to see basically this interface for the database, and they can just enter different fields that they might be want to search for. And Open API, which is built into Fast API, allows you to automatically query the database without really having to write any code. And you can just, there's like a field that lets you enter like what activity you're searching for, and it'll return all entries in the database that match that activity, for example. And there's a bunch of other different fields for date or location or station ID. And you can do this all through basically similar to like a form, but without having to write any code to access the API. And also Fast API just has some performance benefits versus Flask, where it's a lot faster, which can support larger workloads and more use for the system. Additionally, we were also looking to migrate the service from an on-premise hosted solution, which is what Gallery 2 is, to something that's completely hosted and deployed in a public cloud environment. this really reduces kind of the physical maintenance that needs to be done to manage the database and to ensure that servers are up and running all the time, which is a big priority for UNAVCO because we're responsible for making sure these services remain up and running and accessible to researchers. And moving to the cloud enables us to do that in just a much more efficient, cost-effective, and mostly efficient way. So again, PyWego is a cloud-based alternative to Gallery 2, and for our API service, we moved that as well to an AWS hosted environment, specifically using a feature called AWS Lambda, which actually requires no server provisioning, and all functionality is provisioned automatically when a request is sent, and then deprovisioned when that request is no longer being processed. So really this access exists in the cloud only when it's needed. And when the API is not being used by a user, it's kind of in a hibernation state where we're not being charged for running a physical computer system, which consumes electricity and therefore costs money. So with this migration to the cloud services, which improved a lot of things, but it also had a few drawbacks that needed to kind of be worked around. And so previously with Gallery 2, we had access to the entire database structure, and we could really request data in any way that was needed. With PyWego, access to the data is only through the PyWego standardized API endpoints, which is just a set of functions for how you can request data from PyWego, which it's nice because it's standardized and it's the same for every instance, but it's a little bit less flexible than querying something like a Postgres server database, which you can really send an SQL query that can return data in any different shape or size. So to kind of combat this this minor setback, we had to create another secondary database, again hosted in AWS using their DynamoDB service, which kind of cached all image metadata in a format that was much more typical for the data access patterns that the API would see in real world use. So this kind of is on the API side of programmatically accessing large amounts of station data could be done through DynamoDB much more efficiently than through the PyWego API directly. And in order to keep these two databases in sync, because PyWego is separate from DynamoDB, PyWego hosts all the image data through a visual user interface that anyone can go on the internet through their browser and interact with. DynamoDB only stores the image metadata with a link to the image hosted by PyWego. And in order to keep these two databases in sync, I deployed another Lambda function that basically checked log data from PyWego. Script, whatever changes might have been made by a user would be also replicated onto the DynamoDB data. So these two systems work kind of interchangeably depending on how the data is being accessed. If it's being accessed in a visual way through the PyWego gallery, that's handled by PyWego. But if someone's using the API to access this data and they're accessing usually larger quantities of it, that's all done much more efficiently in DynamoDB. And then just to touch more on the Lambda serverless deployment that I spoke about earlier, there are a lot of different ways to deploy an API. Previously, we had it deployed on an on-premise server hosted by UNAVCO. There are also options of deploying it to a full provision cloud server in AWS, which is similar to hosting it by yourself, except you're not managing the server. And then AWS would be managing it. And then there's even further kind of simplification where AWS Lambda is a completely serverless technology, which means you don't have to worry about what the actual computer running the software is doing. All of that is provisioned and handled by AWS. And it is basically designed to be an on-demand service where requests are processed when an API, like when an API request is received, the Lambda function will start up. It'll it'll process the request. It'll return any data that is being requested for, and then it will sequentially be shut down and no longer consume any computational resources, which is really cost effective. And it also just lowers the amount of configuration work needed by anyone in the geodetic data services team. So again, moving along with this kind of cloud deployment model, I utilized AWS Cloud Deployment Kit, CDK, and the CloudFormation stacks within AWS, which allowed us to programmatically deploy the infrastructure such as the Lambda functions, the Dynamo database, and the API gateway, which routes all of the API traffic to the database. It allows us to programmatically provision all of these different systems in a way that's repeatable and predictable, and making sure that we are not paying for or exposing any data that should not be publicly accessible, and none of the costs associated with provisioning lots of servers. That is obviously wants to be avoided because it can be very costly very quickly. So this model kind of overviews the whole system that has been designed. There's a user endpoint who interacts with the API gateway, and the API gateway routes it to a Lambda function, which accesses the database and then returns the data to the Lambda function, which again routes it back to the user who's requesting it from their computer. And then there's also the backend deployment side where any changes made to the infrastructure configuration in AWS is automatically provisioned through AWS CDK in order to basically ensure that these things are accurate and reliable. And if services fail or services go down, they can be re-provisioned in a systematic way that is very fast and very reliable, instead of having to possibly replace an entire server, which could take months. This could take a matter of minutes to completely redeploy the entire service. And so to wrap up, really all that is left in this project is to finalize testing what has been deployed already, and also integrate this project with the GitLab CI/CD pipeline that basically automatically deploys all the code produced by GDS. So this just needs to kind of be bundled up. Right now, everything has been deployed manually, but it's really a matter of integrating things with GitLab so that everything will run automatically and there will be no sort of manual oversight required. And so that really wraps up my presentation. I really want to thank everyone at UNAVCO for just the wonderful experience. I had a wonderful time learning here. Thank you, Anika and Kelsey, as well as Doug, my manager, and everyone else for making this opportunity great. My funding was sponsored by the CSA Agreement 1724794, which is the Gage Faculty Grant. Thank you, everyone. And now I can open the floor to questions.
That was great. Glenn, you have a question?
Again, it's more of a comment and praise. for moving this forward. I want to really thank Ian and Doug and many other people that were involved in prototyping this system. As the noted director, it's very exciting that we're able to move this to more modern technology and make it more functional for both the community members and the field engineers that need to get access to this data. So thanks a lot, Ian, and thanks, Doug, for supervising.
Okay, any other questions? I have one where people think and talk, type. What was one thing that surprised you or you thought was like, ooh, wow, I wasn't expecting that?
I think he's muted.
Hello, Ian?
Sorry, I was muted.
Oh, okay.
But my apologies. I mean, I was really kind of surprised at how much trust Doug afforded me to kind of own this entire project, because it is something that really touches on it seems like it touches on a major part of what UNAVCO works on, and really every station deployment seems to use this service. So getting to work on a project that was so crucial and that was used by so many people internally at UNAVCO was really a surprise, but a welcome surprise, because I like having like knowing that my work is having a real impact on the world, and I'm hoping that the system sees a long future ahead of itself and is used by people at UNAVCO for a long time to come.